Sorry, I had a frog in my throat. Welcome to lesson 116. We are going to discuss the quotient rule for square roots. What that means is we do not like to see square roots with fractions in them. Let's put a 2 here. We don't like to see that. That doesn't make any sense to us. It's an irrational number for sure. But we can simplify this and we can rationalize it so that it makes more sense. And the way we do that is we separate these two numbers and make them both radicals. So it looks like this. This is the same value as this. Now we know when we have a square, we can multiply it by the same square and turn it into a factor. So if we multiply both the top and the bottom times the same number, which in this case is going to be the denominator, then we end up with square root of 6 over 2. Because the square root of 2 times the square root of 2 is 2. Now this can actually be used in an equation. We can get to a common denominator with another fraction by turning this denominator into an actual whole number or an integer. So that is why we want to do this. We want to be able to perform some calculations, add like terms, so forth and so on. But we can't do that if we can't get to a common denominator. So first, we want to get it back to a whole number so that we can do that. The top doesn't matter. We can treat it like a variable. If it's still in the radical, that's fine. We just treat it like a variable and we move on. But we want to be able to use the denominator to find the common denominator. In order to do that, like I said, it has to be an integer. Okay? Or in this case, the denominator is always going to be a whole number. So let's look at 116.1 and write this in simplified form. Well, we're going to do the same thing we did before. We're going to separate them into their own radical shapes or their own radical symbols. Then we're going to multiply times the denominator, right? And that's going to equal the square root of 15 over 3. Okay? Now look, we cannot divide this and say the square root of 5 is our answer. That's just not the way that works. We have to leave it like this because this is an irrational number. This is a rational number. So we are going to leave them separate. We're not going to try to divide them even though we know that 3 is a factor of 15. It just doesn't work that way. Okay? So let's do 116.2. We have a fraction now. We have 4 plus the square root of 3 over the square root of 2. So we need to multiply both of these times the denominator. So that's what we're going to do. So in this instance, we're going to go ahead and do it like this, and we're going to use the FOIL method. Or we're going to use the distribution process since we don't have two binomials. But we're going to do the first term and then we're going to do the last term times the square root of 2. So that's going to be 4 times the square root of 2 plus the square root of 6 over 2. Okay? And that's as far as we can go. That's all we can do with that. All right. Let me clear the page. Let's do some more. We have one more, 116.3, and it says 2 plus the square root of 15 over the square root of 5. So we're going to multiply times the square root of 5 times the square root of 5, and that is going to equal 2 times the square root of 5 plus the square root of 5 times 15 is 75 over 5. Okay, this can be simplified. So let's rewrite it down here. 2 times the square root of 5 plus, and 75 is going to be 3 times the square root of 5 times the square root of 5, right? That's 25. 3 times 25 is 75. So now that we know we've taken these two squares out, we can make that 1. So that ends up being 2 times the square root of 5 plus 5 times the square root of 3 over 5. And that's because we took this pair of 5s out of the square root. Now, I typically do this like this. I typically write it like this. I typically say square root of 75 equals 3 times 5 times 5. Same thing as what I did over here. And I pull this out, and what's left goes back in the radical. So 5 times the square root of 3. It's the same thing I got down here. But you can break it up, and I was just using that to illustrate this point here, that the square root of a number times the square root of the same number is that number. And we see that. Okay? So that is the answer to this. All right, that's all we have for lesson 116. That was less than 10 minutes, guys. I will see you in lesson 117.